Good evening, everyone, and welcome to another Orland Park Public Library virtual program. Tonight we have Stormwater Management, and we are going to learn about where our water comes from in Cook County. Tonight we have a staff member from the Metropolitan Water Reclamation District of Greater Chicago. His name is Edward Jenkins, and he will be giving us a brief history and overview of the mission that the Metropolitan Water Reclamation District of Greater Chicago has, and they will be discussing the role and the status of the Tunnels and Reservoir Plan. And he's going to explain how the green infrastructure can be used at home to help manage stormwater. And finally, he's going to explain the importance of water conservation in a water-rich area. So without further ado, I'm going to pass it off to Edward.
All right, thank you for that introduction. And let's see. Are you able to see my screen?
Yes.
Perfect. All right. Well, good evening, everyone, and thanks for having me. As you heard, my name is Ed Jenkins, and I'm an associate civil engineer with the Metropolitan Water Reclamation District of Greater Chicago. We know that's a mouthful, so we're also called the MWRD for short, or simply the district. I'm here to talk about how the district helps protect our waterways and the water environment, and how you as residents of Cook County could also get involved in protecting the water environment. So to begin, I want to go over a brief history of what the district is and what we do. We were established in 1889 as the Sanitary District of Chicago to address the issues wastewater were creating from a booming population. Our primary responsibilities are reclaiming wastewater and providing stormwater management for the majority of Cook County, which today is a flow equivalent of nearly 10 million people. Our service area encompasses 883 square miles and includes the city of Chicago and 128 suburban communities throughout the county. To understand why the district came about, we need to go back in time to early Chicago history. You can see in this lithograph how Chicago was in 1820. At this time, there were fewer than 100 permanent inhabitants, and you can see that the land the city was built on is naturally a marsh with vast wetlands throughout the area. But by 1860, just 40 years after that lithograph was made, Chicago had become a major transportation hub of the United States, with travelers and goods moving through the area by primarily railroad and ships. And the population
I'm sorry to interrupt you real quick. Someone asked in the Q&A if you could speak up just a little bit. They're having a hard time hearing you.
Sure. Is this any better? Let's see if I can adjust a little bit. Okay. So let me get restarted here. So this is Chicago as it was in 1860, 40 years after that previous slide showed. And you can see that the area is vastly more developed. And in just 40 years, the population had gone from less than 100 to over 100,000 people. And this was driven primarily by the railroads being built across the country and the shipping, which you can see here, transporting goods and travelers from the Lake Michigan through the Illinois and Michigan Canal and off to the Des Plaines River. Let's see. Didn't freeze. Cool. So due to the low-lying nature of the land, the first sewer systems built in the city were actually located above ground so that they can use gravity to flow to the rivers. Combined with constant flooding of the area, this brought about a number of health and safety problems. So in 1856, the entire city, including the existing buildings, streets, and sidewalks, were actually raised on jacks and filled beneath approximately 5 foot above where they were previously. By doing this, the city and surrounding communities could begin building below grade sewers, like you can see here. Um, these were built before wastewater treatment existed, so they were designed to take stormwater and sanitary sewage and send it directly into the surrounding rivers. When these sewers were built, they carried a lot less water than they would today, simply because there was more open area at that time. There was much smaller houses and buildings, so the runoff from their roofs and downspouts was significantly less. And there was also much less intense storms than what we've been seeing, especially over the last few years in the area. So, with a small enough population, the rivers and lakes can actually clean the sanitary waste through natural processes. But after 1860, the population of the city nearly doubled every 10 years. And by 1890, it had already reached 1.1 million people. This population density was too much for the local waterways to handle, and in 1885, a major storm flush polluted river water out into Lake Michigan near the water collection cribs, causing concerns about public health and what would happen if sanitary waste was taken in by the drinking water supply. So, as a direct response to this, the Illinois legislature approved the Sanitary District Enabling Act in 1889, and it was that act that founded the district later that year. In this picture, you can see how the rivers originally flowed, with the Des Plaines heading west and the Chicago and Calumet rivers heading east into Lake Michigan. You can also see the subcontinental divide that separates the Des Plaines River and the Chicago area waterways. The divide actually separates the Great Lakes watershed from the Mississippi watershed, meaning that everything east of it flows to the Great Lakes, and then everything west of it flows all the way to the Mississippi and ultimately into the Gulf of Mexico. Some municipalities are built on land that was formerly lakes and marshes, and as a result, drainage is a constant struggle for the Chicago area because of the natural tendency of the landscape to flood. But the district took advantage of the subcontinental divide and concocted a plan to protect the lake by reversing the flow of the Chicago and Calumet rivers away from Lake Michigan. To do this, the district constructed a 61-mile system of canals and deepened and straightened and even widened the waterways to move more water through the system. The canals cut straight through the subcontinental divide and allowed the rivers to flow by gravity away from the lake. So you can see here a photo of our operations from 1895, where we use drilling and blasting methods to clear out the area. The district completed construction of the Chicago Sanitary and Ship Canal in 1900, followed by the North Shore Channel in 1910 and the Calumet Sag Channel in 1922. So the polluted water from these rivers was now sent through a system of canals away from the lake and to the Des Plaines River, where it was diluted and it flowed eventually into the Illinois River and then down to the Mississippi River. This was actually a huge achievement and won a lot of accolades. And the lessons that they learned here were actually applied to the Panama Canal that opened up shipping between the Atlantic and Pacific Oceans. Um, so initially, this arrangement of sending our wastewater essentially to downstate Illinois as opposed to our drinking water supply was agreeable because by widening and deepening the river system and connecting the Great Lakes to the Gulf of Mexico, we've increased economic opportunities in the area. But as the city continued to expand, the ability for the lakes and rivers to dilute that sanitary waste and to clean themselves continued to diminish. So by the 1910s, the district decided that treating wastewater before releasing it to the waterways was the only way to protect citizens and the environment. And over the next 60 years, the district designed and built about 560 miles of intercepting sewers and 7 water reclamation plants to address the growth in the area. By the 1950s, the district was actually capturing roughly 1 billion gallons of combined sewage and stormwater every day. And today we treat almost 1.5 billion gallons of water every single day. So you can see here simplification of the combined sewer system in Cook County. In order to get the treatment plants operational as quickly as possible, the district built intercepting sewers along the waterways and connected them to the existing municipal sewers. You can see the municipal sewers that still have a connection to the area waterways and the district interceptors that carry flow to our water reclamation plants. Um, This is a schematic of a wastewater treatment process that is typical at our plants. There's kind of a lot going on here, but in a nutshell, the wastewater enters the facility and is screened for large debris so that anything bigger than about 3 inches will be caught up in bar screens. It is then pumped from there for the first and only time to the grit tanks to remove larger particles like sand and gravel, which can be harmful to the facility's infrastructure. From those tanks, it enters another series of settling and aerated tanks that utilize biological processes to treat the water. What we're doing in the aerated tanks is basically supercharging the natural processes that take place in the lakes and rivers to clean the wastewater. And the last step at most plants is the final settling tanks, where the biomass is removed and clean water is released into the environment. Um, 2 of our plants actually go beyond final settling and utilize disinfection as the final step in their treatment process. The Calumet plant on the south side uses chlorination and dechlorination, and the Terrence O'Brien plant on the north side uses ultraviolet light to reduce the number of microorganisms in the water before it's released into the environment. In case you were wondering, the wastewater from Orland Park flows to the Calumet Water Reclamation Plant, which has been in operation since 1922, and it treats anywhere between 350 and 430 million gallons of wastewater every day. This water is discharged into the Little Calumet River, and at 99 years old, the Calumet Water Reclamation Plant is the district's oldest facility. So, as I mentioned before, the direct connections from the sewers to the rivers are still in place. These were left to protect areas from flooding during wet weather, but as the city continued to grow, combined sewer overflows, otherwise labeled here as CSOs, became more and more common. So by the 1960s, CSOs were happening around 100 times every year, and they were having a negative effect on the local waterways. That's where the Tunnel and Reservoir Plan comes in. So since the 1970s, the district has been building a system of deep tunnels and massive reservoirs to address the problem of CSOs. This is done by capturing excess flow from the local sewers when there is a precipitation event. The system works by acting as a second set of interceptors that capture the overflow and hold it in the reservoirs until it can be treated at district water reclamation plants. So the entire project is being carried out in two phases. The first phase started in 1973 and was completed in 2006 and involved the construction of 109 miles of this large diameter tunnels. They range in size from anywhere from 8 foot up to over 30 foot in diameter. The second phase consists of constructing 3 reservoirs for flood and pollution control for the Chicagoland combined sewer areas. As of today, the Majewski Reservoir and the Thornton Reservoir are fully operational and have significantly reduced overflows in their service areas. The McCook Reservoir is partially complete and operating at 35% capacity. When that reservoir comes fully online in 2029, it will provide a total of 10 billion gallons combined sewer overflow retention. Once the entire TARP system comes online, it will have capacity to store 20.5 billion gallons of wastewater that could have otherwise ended up in local area waterways. So here's a photo of the Thornton Composite Reservoir. In 2015, this reservoir came online and it is currently the world's largest of its type. Just like reversing the river, this one is the world's most ambiguous engineering projects, and it's expected to be in operation for the foreseeable future. We never expect to take these systems offline. Located at the southern end of Cook County, just north of the Tri-State Tollway, which you can see there. That's not, has that question and answer been in your way the whole time? I'm sorry. Sorry, the Thornton has a capacity of 7.9 billion gallons of stormwater and benefits 14 communities, and to date has prevented more than 39 billion gallons of CSOs from entering the area waterways. It's kind of difficult to gauge something on that's this large of scale, but this can fit 12 soldier fields in it. If you can visualize that, it'd be 2 rows of 3 and then another stack on top of that. Here you can see the McCook Reservoir. This is actually just stage 1 of the reservoir. When completed in 2029, this will be able to hold a total of 10 billion gallons. This phase 1 is able to hold currently 3.5 billion gallons and came online in December 2017. Again, at this scale, it's kind of difficult to tell how big this is, but if you can see this truck here, it's actually a 20-foot by 40-foot truck that weighs over 200,000 pounds. So these sites are massive. So this is inside one of the tunnel and reservoir tunnels. The drop shaft, deep tunnel, and reservoir design of the TARP system was actually the first of its kind. but it has now been incorporated into stormwater management of other cities, including London, Singapore, and Vienna. And since the TARP system began coming online in the 1970s, the number of fish species in the Chicago River system has grown from just a few. You can see here it's approximately 10 in 1974. And as of 2020, we were able to identify more than 70 species of fish living in the Chicago area waterways. According to recent study done by the Shedd Aquarium and the district, since 2001, a total of 19 new species have been captured, of which only one of those was considered an invasive species. So there's been a large increase in native fish species populations. The results indicate that local Chicago waterways are more ecologically productive and conducive to aquatic life and less degraded than they were even just 50 years ago. So now you know how the district treats waste and stormwater, but with continued development and worsening precipitation, we also encourage the residents of Cook County to lend a hand in protecting the water environment. Along with community partnership opportunities, the district also has several programs and resources for Cook County residents. Uh, One such resource is the Green Neighborhood Guide. This guide is designed for homeowners and provides step-by-step instructions on how to manage stormwater on residential properties using green practices such as rain gardens, permeable pavement, rain barrels, and cisterns. Um, this guide is available at the link here, or you can go to our website at MWRD.org. Um, so here are just some examples of green infrastructure that can be done at home. Permeable pavements include any type of pavement that allow water to flow through it. After water flows through the pavement, it slowly filters through a gravel layer installed below that allows the water to soak into the soil. This lets rainwater be absorbed into the ground rather than into the sewers and helps reduce basement flooding while also recharging the groundwater table. Rain barrels and cisterns allow residents to collect rainwater for later use. This helps reduce the amount of stormwater entering the sewer system and provides a free source of water for cleaning or irrigation or just for personal use. Collecting rainwater is environmentally friendly practice because Lake Michigan water is a very precious resource. Um, and then green roofs and rain gardens are forms of bioretention systems. These are engineered systems that utilize plants and soil layers to retain stormwater and filter contaminations from runoff before it soaks into the groundwater table. So here's another one of the district's programs. The Small Stream Maintenance Program began in 2006 and follows district stormwater management mission to relieve flooding in urbanized areas through immediate and relatively simple remedies. The objective of the program is to remove obstructions and debris in the waterways that impede the natural drainage of small streams and rivers. Since the inception of the program, we've removed approximately 350,000 cubic yards of debris from Chicago area streams. Residents can take advantage of this program by reporting any blockages or any streams that need maintenance on our website by going to it and filing an incident. And then the rain barrel program we have, the district actually offers these at cost and will deliver them to the residents. of Cook County. Um, these can be ordered online on the district website, and they're easy to install. They come with all of the hardware you need and include spigots and mosquito nets so that they don't become a vector or a breeding ground for anything that shouldn't be in there. And one of the other programs the district offers is EQ biosolids and compost. These are a product of wastewater treatment that supplies organic matter and improves the structure and porosity of soils, which allow plants to more effectively utilize nutrients. They can be blended with topsoil and potting soil for new plants or used as mulch around established plants. Biosolids have been used to improve soil quality at a lot of popular destinations like Maggie Daly Park and the 606 Trail on golf courses and athletic fields at both public parks and schools in the Chicago area for more than 20 years now. The district actually offers biosolids to residents free of charge, and they can be picked up at the water reclamation plants, or you can schedule a delivery online. If you are interested in a delivery, you'll actually need to order at least a minimum of 10 cubic yards. So you you'll need to plan for that. Okay. So even with the massive projects the district's undertaken, there have been an increase in flooding and sewer backups in recent years due to excessive rain events. So are some things residents can do at home to protect themselves, such as having your lateral sewer pipes inspected, disconnecting your downspouts from the sanitary sewer, and installing a sump pump. Other options that can be quick include using a standpipe. Some of the others that are a bit more costly but offer a higher level of protection include installing check valves or an overhead plumbing system in your home. But with gray and green infrastructure, there's only so much we can do. Effective green infrastructure implementation requires a culture change. Individuals of all ages really need to start taking responsibility for our water environment. We need to be conscious of our water use and be mindful of not wasting this precious resource. In addition to implementing a form of green infrastructure, such as installing and using a rain barrel to water plants or wash your cars, actions can be as simple as fixing leaking plumbing fixtures. Um, don't run water to bathe or wash clothes or dishes before and during rainy weather. This allows the maximum capacity in the sewers by reducing the amount of water coming from residential areas. Uh, Make sure you always fully load laundry or dishes before running a cleaning cycle. Take shorter showers. Turn the water off when brushing your teeth. Install water efficient fixtures or aerators. Use native plants that are tolerant to the local climate instead of grasses that need to be watered. Besides using less water, there are other things individuals can do to help improve water quality and prevent flooding. Removing litter and cleaning inlets. We frequently find plastic shopping bags in the waterways or in the sewers, so we encourage people to use reusable bags, especially when grocery shopping. Um, Now might not be the time for that because I know a lot of stores are not allowing personal bags being brought, but when it's possible, please consider using more sustainable options than plastic. Make sure you always clean up after your pets. Uh, pro- Properly dispose of unwanted medications. we ask that you please do not flush medications down the toilet or down the drain, because they can end up in they do end up in the wastewater, and it can be very difficult to clean those out at the plants, and then they can end up in the environment. The district has a medication not recycling, but collection program that you can drop them off at drop boxes in front of some of our facilities. And finally, don't oversalt during the winter. This can have detrimental effects, not just on the plant life and groundwater in the area, but it also ends up running off into the sewers and into the water environment. And we've seen an increase in salinity in the Chicago area waterways, with an increase in bad winter weather because of oversalting. The last thing I want to mention today is that if you're interested in learning more, we are currently offering virtual tours of our facilities, including the reclamation plants, going into our TARP system, learning about our laboratories, and actually following along on our fishing sampling operations to see how we calculate how well our systems are doing. Please join us for an informative session. The next one is going to be held on Wednesday, April 14th at 10 a.m. and you can register on our website. And that's all I have to share with you tonight. If you have any questions, I believe we still have quite a bit of time, and I'm here to answer whatever you have.
I wanted to hop in with a quick thank you for doing this program for us and allowing us to record so we're able to share it to more people on our Facebook page as well. We have a much larger audience on our Facebook page, and I hope all of you guys are watching that you were able to get some of the information down that he put in PowerPoint, and if not, you can always rewind it and get that again. I hope you guys are able to join in on the virtual tour that he was talking about at the end. I think that would be very helpful. You know, any steps we can take to help our environment, and especially our water system, because I think it's something that we take for granted is our clean water. And I hope that everyone was able to learn something today and we got something really good out of it. And once again, thank you for doing this for us.
Of course, thank you for having me.
It doesn't look like we have any questions for right now. So I think we might be good for the night. So once again, everybody, thank you for coming out tonight and coming to another edition of an Orland Park Public Library virtual program. And here we go with the with the name. I know you gave us the abbreviation, but I like to say the whole name just in case people want to look it up. So thank you to the Metropolitan Water Reclamation District of Greater Chicago, MWRD, for doing this for us. And if you guys want to look more into what they do, as you see, we have the link up right there if you want to register for a tour, and also it'll take you to their website. Thank you once again to Ed. Thank you, audience, for coming out, and have a good night, everybody, and soon to be a good Earth Day. So have a good night, everyone. Thank you.
All right, thank you again for having me.